Hello, I'm Richard Gehring. I'm here at the Design Automation Conference 2011 talking to Thomas Moerth, who is Manager of Design Support at Austriamicrosystems. Austriamicrosystems is an analog IDM located in Graz, Austria, and a Cadence customer. Well, Thomas, Austriamicrosystems is known for analog IC design. We're talking about mixed signal today. What kind of mixed signal design work do you do?
Well, you know, most of the analog projects we do have a small digital part in them. Maybe a small microcontroller that does like a sensor calibration or a bus interface. So all our projects are big A, little d projects, and we're talking about 10 to maybe 50K gates in our projects, but that's it, and that's our mixed signal.
Okay. What are your biggest challenges in mixed signal implementation?
At the moment, the biggest challenge for us is the top-level simulation. Here we are trying to find a good compromise between the simulation accuracy and the simulation speed, and we're on a good progress there, but there's still way to go.
What approach do you use for that top-level simulation?
That depends a bit on the project, but we are mainly using AMS Designer. And then depending on how big the analog part really is, we choose the analog solver to be either Spectre or APS or UltraSim, and have the digital part simulated.
Okay, great.
In NCSim.
Now, you recently completed a mixed signal sensor project. What can you say about what this project involved and where the digital logic came from?
Yeah, so the project we did on our way here, that was a shared project we did with one of our customers. Our customer did the digital RTL netlist, and we, so to say, did the rest, all the analog part, synthesis and place and route of the digital part.
Okay. And I understand you used open access as a way to communicate between the digital and analog environments.
That's correct.
Between Virtuoso 6.1, is that right? And,
yes.
And Counter on the digital side. What was the advantage of doing that compared to a left-def file transfer?
Well, the most obvious part here is that the handover of design data between Virtuoso and Encounter is way easier in 6.1 than it used to be in 5.1. Because there's no more writing out of left-def and no more read-in. If you change something in Virtuoso, it's immediately there in Encounter. That's the best thing. So our guys like at most the easy handover and of course the easiness of floor planning, which traditionally is done in Virtuoso and AMS.
Does floor planning become more of a cooperative effort between the analog and digital teams with open access?
Inside Austriamicrosystems, this is usually done by the layout team, by the analog layout team. So they communicate to the digital teams how big the area will be that they need. But then, so to say, the constraints come from the analog part. All the analog blocks are placed, and then the space left has to be used by digital.
Okay. With open access, do both analog and digital teams have full visibility into blocks coming from the other side?
Yes, they do.
Okay. Can analog designers change digital blocks and vice versa?
In principle they can, but that's hardly done at AMS. So usually the guys keep to their tasks in analog and digital. They don't mess around with the other things.
Yeah, I understand. Analog designers in particular, very particular, don't change this. Can you put constraints in there saying don't change this? Yeah. Okay. How are pin adjustments handled using open access?
In principle, again, we did that in Virtuoso. We changed the pins, wrote that to the abstract, and then just passed the abstract to Encounter.
Okay. And do you pass constraints between the analog and digital team with open access?
Not in a dramatic amount. So what we did is that we mainly had area constraints that came from the analog part going into digital, and the constraints for the digital place and route came from the digital design team.
Okay. And finally, do you plan to use open access for future design work?
Yes, definitely.
Okay. Thank you, Thomas.
Thank you very much.